Okay. So it says the function is continuous on the closed interval from -2 to 7 and consists of 3 line segments and a semicircle. The function is defined as the integral from -2 to x squared of f of t dt. And it says find g of 2, find g prime of 2, and find g double prime of 2. Okay. So to find g of 2, we can rely on g of x. That's just adding up areas inside this geometric shapes. But I want to talk about how to get to g prime and the g double prime so that we can involve 2 at those values. So if I want to find g prime of 2, I need to find the derivative of g of x. So I'm going to write g of x down here again. If I want to find g prime, I have to involve second theorem because I have to find the derivative of this expression. Okay. And second theorem says that if I want to find the derivative of a definite integral from a to p of x, these 2 operations are going to cancel each other out, but the upper bound is going to have some impact. So it's going to be lodged into the variable of the function, and there's also a times p prime. So I'm just going to apply that process for this problem here. These 2 operations cancel each other out. The upper bound gets inserted in for t, so I get f of x squared times the upper bound's derivative, which is 2x. Okay, does that make sense here?
Yeah, wait, let me copy down the stuff at the top.
Second theorem here.
So does that applies for any equation, right?
It applies for anytime I'm finding a derivative of an integral. If the integral is part of my function and I want to find the derivative, whenever I see these 2 opposite operations next to each other, I'm going to be applying second theorem.
All right. Okay.
So now I want to make my way down to g double prime. So g double prime, look at g prime. G prime has 2 components. You see how they're being multiplied together?
Yeah, just like the first one, right? Or no, that's one component.
Well, no, g prime is just this. Yeah, so there's no more. We don't want to do any second theorem anymore. But if I want to find the derivative of something that's in this form, I got to go through product rule. You see how these are.
I couldn't remember the name of it, but I know what product rule is. It's like f prime plus g, f prime times g plus f times.
You got it. Yeah. So I'll spell out the different parts that we're going to have to fill in. So f prime, what do you think the derivative of f of x squared is going to be?
So, is it just the derivative of x squared, or is it?
It's a derivative of f and x squared. You see how this is a function within the function?
It's like chain rule, right?
Yeah, it's a little bit of chain rule.
Okay, so it's f. So it's f prime of x squared times 2x.
Yeah, that's the full derivative of that f of x squared. Good. All right, so times 2x, yeah, no changes, and then back to f. And then g prime becomes 2.
All right.
All right, now we have all the tools that we need to be able to evaluate each and every one of those.
Okay. Do we not have to simplify though?
That's okay. We'll simplify it later.
All right.
All right, so let's find g of 2. So g of 2, let's enter it in and see how this graph is going to help us out.
-2 to the 4th, -2 to 4.
Yeah.
Interval. F of. Wait, so would that be f of? It's f of t, right?
Still f of t, yeah, which is okay. F of t, we can treat this like f of t. That's fine. So now we just have to total the regions between -2 and 4. So it's going to be a semicircle and a triangle.
Semicircle is 1/2 pi r
Squared.
Squared. Okay, yeah.
Mm-hmm.
So let's see. 1/2 times pi times this radius is 4, so 16, right? The radius is 4, right?
Radius is 2. Center to the circle.
Oh, you're right. That's my bad.
Yeah. So I think it's just going to be 2 pi. Okay. 1/2 base times height.
Base is 2 times 2. So it's really just 2.
Mm-hmm. So there's my g of 2.
All right.
So now let's find g prime of 2.
G prime of 2 equals f of 2 squared times 2 times 2. All right. Equals. So f of we have to find what f of 4 is, right?
Right. What's f of 4?
Do we have an equation written for 4?
Oh, we should use this graph.
What would it be? Oh wait, 4. That was my bad. No, it's 0.
0. Okay.
I was looking for 4 on the y-axis.
I see.
Equals so it's just 0.
Yeah.
All right. And then g double prime of x equals. Do you want to simplify it now? Or g double prime of 2.
You can. I don't know if it's worth the trouble. We're going to have to multiply everything out anyways. So it's up to you. I'm just going to leave it alone. I'm just going to enter 2 in for x. Yeah, that's fine. We can. 2 squared. All right. Did you get what I got?
Yes, so far.
Okay. So how can we use the graph?
Well, f of 4 equals 0.
Mm-hmm.
So we can just cross that out.
Mm-hmm.
And then f prime of 4. You just find the derivative of 0?
Well, what's another word for derivative?
The slope?
Yeah. Let's just find the slope of the graph at this point, which is a part of this line.
Okay. Which is, it's a -2.
Yeah.
Right? Yeah. Where's it around? Yeah, -2.
Yeah. All right. Plus 2 times 0. Just negative.
Right. All right.
All right. That's
So
h of x equals f of 5x minus 9. Find h prime of 3. So we want to find the derivative at 3. Before we find h prime of 3, let's go ahead and find h prime of x.
okay.
What's involved here, though? Put this over.
Chain rule?
Say it again?
Isn't it chain rule?
Chain rule, yeah. So there's an outside portion, there's an inside portion. Outside is the f parentheses, and the inside is the 5x minus 9. All right, outside first.
All right, let's see. That time would be wait, it would just be f prime of 5x minus 9.
Mm-hmm. Times.
Times 5.
Mm-hmm. All right, now that we've achieved h prime, we can now enter 3 in.
All right, so h prime of 3 equals 5 f prime of 5 times 3 minus 9. So 5 times prime of 2 minus 9, 6. So it's 5, yeah, exactly. All right, and then f prime of 6 at 6, it's just the slope is 1.
Mm-hmm.
All right. So it's 5.
All right, h. All right, 5 is the answer.
Yep.
All right, number 3, evaluate the definite integral of f prime of 3 minus 2x minus 4. You see how there's a minus sign in between? These are really 2 separate integral problems. So we'll split them up into 2 problems here. All right, any idea how to handle this portion?
The one on the left?
Mm-hmm.
Chain rule?
Well, it's chain rule for integrals. What do we call chain rule for integrals?
Not sure.
It's U substitution.
Oh.
Because U substitution will allow us to take a messy problem and hopefully turn it into an easier one for us to solve. Okay, so our U value is going to be the portion inside the parentheses, and the hope is that we can get this to be a little cleaner so that we can actually have some version of f prime show up, because right now it's just too complex for us to know what to do with the graph.
Mm-hmm.
So we'll go through U substitution, replace the 3 minus 2x as the U value, and solve for dx. Cross multiply.
All right. So f prime of u times du over 2, negative d over 2.
Mm-hmm. All right, there's still some more work I need to do with this. I'm going to push that negative 1/2 out in front.
Mm-hmm.
And I'm also going to do some work with the bounds, because the bounds are right now in terms of x. I want it to be in terms of u so I can get everything on the same page. All right, good so far.
Yep.
All right, let's do the work of converting our bounds here. So let's start with the -1. If x equals -1, then our u value is 3 minus 2x. Three minus 2 times -1, which is
3 minus.
is that right?
Oh, yeah, he was 5. Right.
Okay, yeah, that's right. If x equals
0.
0,
Your sister just got one.
okay, let's move this problem up here. Lower bound was -1, now it's 5. Our upper bound was 0, now it's 3.
Wait, but
Sorry,
can't
F prime, F prime.
Well, can't you are you even allowed to do 5 to 3? You have to flip it.
We can, or we can flip it. We can flip it and change the sign. You can do that. But yeah, we're allowed to do 3 and 5 as well. It's just
harder,
you know,
right?
everything will work out either way. But yeah, if you want to flip the bounds, we can definitely do that as well.
Make everything positive too.
Okay, -1/2 times negative integral from 3 to 5 f prime of u du. So that cleans up to be 1/2 integral from 3 to 5 of f prime.
All right.
Now, we can do this. We can find the antiderivative. We know integral of f prime is just f. So we can just go through the antiderivative. F prime becomes f. And then we can evaluate the bounds from 3 to 5. This is in function notation, so we keep it in function notation. There's no power rule. There's no integral rule we have to know. Just understand that we're making the integral step from here to here. Upper bound first. Minus lower bound.
All right, so we go to the graph.
We go to the graph.
F5 equals -2, and F3 equals 2. So they just cancel out. Equals 0. Right?
Let's see here. Let's see. F of 5. F of 5 is -2. F of 3 is 2. Oh, yeah, they're both same signs, so -4.
My bad.
Now there's still something going on here. We haven't figured out this part yet.
Okay.
But the integral of 4 is just going to be power rule. So 4 becomes 4x, and then we can plug in our upper and lower bound.
It's going to be -1, 0, right?
Oh, wait. Oh, you know what? I forgot to bring that 1/2 through. That 1/2 needs to distribute through, or it needs to multiply. We need to keep it until the end here. So I need that 1/2 here. Oh, 0 minus 4. 3 negatives here, so negative minus 4. So we have -2, we have -4. These are the results of our 2 separate integrals. So then we just combine them together.
Wait, would it be? Oh wait, would it be -4 or +4?
It'll be -4 because there's a minus sign in front.
Yeah.
So that negative is going to be part of my expression, but it's going to be upper bound minus lower bound. So there's a minus between the two expressions. There's a negative with the 4x, and there's a negative with the x.
All right. Jesus. Sorry about that, bird.
No problem.
Go inside, but my house is even hotter. My room's like an oven. It's so annoying. I don't have a fan in there either.
Okay, so that's the first page. How do you feel?
Good. I feel better.
Okay. Let's do the second page. I'll show that here. Oh, done with this page?
Yeah.
All right. This is the second.
Jesus, what is going on over there?
All right, so we have a portion of the graph of f prime shown. The area of the region are all given here. So area is 10, area 14, area of 6. And it's known that f of 1 equals -2. Function is twice differentiable, so that just means it's a smooth curve. At least x to the second power. Selected values of g and g prime are shown. Find all the values of x on the open interval from -3 to 8, where for which graph has a horizontal tangent line. For each value of x, determine whether f has a relative max or relative min, or neither. Okay, so we're basically just going to gather information like we would looking at a derivative graph. So I'm going to label my f prime. Anything above and below represent either positive or negative slope. Anything on the x-axis is a slope of 0. We'll create our slope sign line. We're extending from -3 to 8. Critical points, simply going to be where our x-intercepts are, so 1 and 6.
And 1 and 6. Okay.
Positive slope for the first region, negative slope for the second interval, and positive slope for the third interval. So we can confirm that there's a relative max at 1 and there's a relative min at 6.
All right. So.
All right, questions?
Nope.
Good. All right. Number 2, find the minimum value. So we want to find the understood word in front here is absolute minimum. So we know we have 4 candidates. This is EVT. Okay. There's a very specific way that we have to find our max and min value. We have to involve f of 1 equals -2. This is our starting point, and these are going to be the accumulations of how much is gained in each of those intervals, but this is kind of like the anchor. So we have to always involve this point to help us to figure out the rest of the points on the graph. So we need to also apply this first fundamental theorem variation. This is kind of like a particle motion variation, where we can say final position that I'm looking for is going to be the initial position plus displacement. So x of b is equal to x of a plus however much progress I made between my 2 starting and endpoints. So we're going to have to apply this for each one of our critical points. All right, so let's start with -3. X of -3, I'm looking for x of -3, that's my b value. F of x of 8, that's my starting point. I have to involve whatever they give me. So this is my starting point. I need to know how much progress I made between these 2 points. So I need to go from 1 to -3, because I'm starting at 1 and I'm going backwards to -3. But like you said before, it's easier if we can adjust the bounds to make it easier to read. So now that I have this established from the rule that's given, I'm now going to make it easier for myself. I'll adjust those bounds so I can read from left to right and enforce a negative in front.
So why is it x of -3?
Because we have to test our 4 endpoints. We're trying to find the locations of each of these ordered pairs. But right now, these are sitting at the f prime level. We have to figure out where these actually sit on the graph.
Right.
Yeah, we know the graph is going to rise and fall and rise, but we don't know exactly where these points are, and we're going to have to find them with using our starting point.
All right.
Okay, so f of 1 from -3 to 1. So -3 to 1, that is going to be 10. So
okay, so that's the area right there.
yeah, that's the area, right? We can also think of it as this is the progress that the graph is going to make. That we're going to rise 10 units.
So f of 1 is 0, right?
Well, f of 1 is -2 because of what they gave us here.
Oh, you're right.
Okay. Okay, so we have 1 point figured out. I said that there were 2 critical points, but do we need to test both critical points?
I mean, yeah, I think so.
What are we looking for, though?
Oh, the minimum value. So we wouldn't have to test 1 because we know it's
Yeah.
a max. It's an
Yeah,
absolute.
relative max, there's no chance relative max can be an absolute minimum. So we can save time by just ignoring 1. So we only have to worry about 6. We definitely have to test the endpoints, but we only have to worry about 6. Okay, so we'll just worry about 6. Keep interchanging between f and x. Maybe I should just use use f instead.
Okay.
All right, so f of 6 equals, always starting at 1. That's our anchor point. And then we want to figure out the progress made between 1 and 6. So again, -2. From 1 to 6, that's below the x-axis, so that's -14.
So it's always going to be a -14?
What do you mean?
It's always going to be a negative area if it's below.
That's right, that's below. All right, f of 8. So 1 to 8, we have -14 plus 6, so that's going to be a -8.
It's -10.
So now we have our 3 candidates. Our absolute minimum must be -16.
So it's 6.
Make sure that your answer is the -16.
All right.
And then the x value is not that important. It's just asking for the minimum value, so we really don't have to say where it's located. We just have to say what that value is.
All right.
For number 3, we have h of x is e to the g of x over 3x, find h prime. So if I want to find the derivative of a numerator over denominator, I got to do quotient rule. Let's find h prime of x first before worrying about what to do with the 6.
All right. H prime of x equals. Shoot. Oh yeah. So what would e? It'd be e to the g of x times g of x, right?
Times g prime. Times g prime.
Yeah. Oh yeah.
Yeah, e to the u times u prime. All right, how does that look?
Good.
Okay. We're ready to replace all of our x's with 6.
All right. All right.
Looks messy, but I think things will clean up nicely once we look at our graph.
Okay, so wait, how do we know what the function g of x is?
Oh, we're going to refer to the table now. Now we have the table to help us with g. So we're done with f. Now we're relying on this g table here. So we need g of 6 and g prime of 6. What do you see?
Sorry, I'm copying the table down real quick.
Okay.
Okay, so e to the g of 6 will become e to the 0.
Yeah.
It's just 1.
So yeah, g of 6 is going to be 0.
Times 1, so it's just all 0. Times 18, so it'll... Wait, e to the 0, does that become 1 or 0?
It becomes 1.
Okay, so it'll be 18 eventually, but minus e to the 0 again times 3 over 18 squared root over 324. Okay.
So 18 minus 3, do you get 15?
Yeah, over 324, right?
Mm-hmm. And that reduces to be 5 over 108.
All right.
All right, number 4. Is there a time between 1 and 9 such that g prime of c is equal to negative 1/2? Does the wording remind you of anything that they're trying to tell us to use?
Is there a time between... I'm not sure.
Okay, so here it says, can we guarantee a slope of negative 1/2? So anytime we are involving guaranteeing a slope of a G graph, that's going to be a reference to mean value theorem.
Okay.
So mean value theorem says, if the slope between the endpoints produces this value, then we know we can guarantee that there's a specific slope value of this number here. So here's mean value theorem. but we can adapt it for our g function here. Our a and b values are 1 and 9.
All right.
And we just rely on our table, g of 9, g of 1.
-1 minus 3.
Yeah, -1 minus 3.
9 minus 1 equals -4 over a equals -1/2. Aha.
Yeah. We can guarantee the slope between the endpoints is -1/2. Our graph is told to be twice differentiable, so it's continuous and differentiable. So that because the slope between the endpoints is -1/2, there must be a specific slope on the graph that is exactly -1/2.
Right.
So we can say by mean value theorem, since g of x is continuous on the closed interval from 1 to 9 and differentiable on the open interval from 1 to 9, there must be at least one value on the interval from 1 to 9 such that g prime of c is equal to 1/2.
All right. So when we answer the question on like the exam, we have to write all of that.
If it's free response, then yes. Continuous on the closed, differentiable on the open. We want to make those statements. But I'll show you. I was going to show you that the formula sheet has all that on there, so you can just reference the formula sheet and then just copy down those conditions. Yeah, right here. Oh, no, I don't have it. Okay. I created a formula sheet that I'm going to attach to your quiz where you can just reference all the rules there. Okay, one more to go, number 5. We want to find a definite integral of something that looks a little messy. What do you think we can apply to make that a little bit cleaner to work with?
Okay. Oh wait, can't we divide it? No, we can't divide it into 2 different ones. Chain rule?
Integral, what's the integral for chain rule?
You talked about it.
So look at the previous problem. What did we do that was similar to this process on the previous problem?
We use mean value theorem.
Yeah, U sub.
Oh,
Yeah, basically we take a messy integral and clean it up to a point where it's easier to work with. Okay. So our U value is always going to be that portion inside our parentheses. So we're going to target this, replace the dx, and then hoping that the g prime will go away when we go through that process.
All right.
Solve for dx.
U over g prime of x.
Mm-hmm. We'll make our substitution. Leave the bounds out of it. We're going to have to do some work with the bounds.
So we got u squared du.
That's right. G prime goes away.
So do we find the antiderivative of that?
Yes, we'll have to find the antiderivative. But before we do that, though, let's get the bounds ready. So we have to adjust the bounds, right? Because right now it's out of place. This is in terms of x, but our expression is turning into in terms of u. So we'll convert the bounds.
Okay.
If x is equal to 1, our conversion rate is g of x, so g of 1. And what's g of 1?
Crap. Sorry, g of 1 is 3.
Yeah.
But is it not -1 on the thing? Oh, it is just 1. Okay, I wrote -1 by accident.
Oh, I see. Yeah, so it's just positive 1. G of x. And g of 4. P1.
G4 equals 1. All right. So then,
So now we can get it all set up here. We have the integral of u squared du from 1 to 3. We go through power rule. U squared becomes u cubed over 3. And then we can plug in our upper and lower bound.
all right, so do we convert that back to x?
Oh, wait. Oh, you know what? My bounds are out of order here. I put the 3 above. It should be below.
Okay.
I mean, we could always put a negative outside, but I want to show where it was at the beginning.
So it'd be
Yeah.
1.
I don't know if it's worth the trouble to flip the bounds because we're just going to plug into the formula. We don't have to read a graph. You can, but you don't have to. So whatever I start with my lower bound, I need to keep in my lower bound. Whatever I start with my upper bound, I need to keep in my upper bound. So they need to begin in their correct locations, and then we can flip if we want to later on. But I think I'm just going to keep it the way it is. Okay, upper bound first. 1 in for U. Lower bound. So I get 1 minus 27, which is negative 26 over 3.
All right.
All right, so you got your homework 9 finished, and this is yeah, that's good. That's they're able to. I think you should feel more comfortable. I think you should be able to make progress on the other assignments. You know, you kind of seen everything here within these 2 pages here. So at least with the types of problem, the type of concepts I'll be asking on the FRQ next week.
All right, well, thank you very much.
Yeah.
For meeting with me.
I'll have a good weekend. I'll see you Monday.
You too. Have a
Okay,
good weekend.
Okay, thanks. You too. Bye.
Bye.